Okay, so we are moving on to indicator 22.2, and you will see very quickly why we did 22.1, which was simplifying radicals. You'll see why we did that. So indicator 22.2, and it is, I always have to look at this because I always want to spell it wrong, Pythagorean theorem. It's actually one of my favorite parts of 9th grade math. I love it. I'm such a nerd, though. Pythagorean theorem. Give everybody a minute to get that written down at the top of your notes. All right, so the Pythagorean theorem applies to right triangles. And we know any triangle is a right triangle because it always should have a little square in one corner. Does anybody know what that square set means? What the angle is? 90 degrees, okay? Every right triangle has a 90-degree angle in it, and that indicates that you can use the Pythagorean theorem to solve side lengths. Now, the Pythagorean theorem is a squared plus b squared equals c squared. A squared plus b squared equals c squared. Is this review for anybody, or is this new? I'm not sure what you do in 7th grade. New? Okay. All right. So when you have a right triangle, the two legs that make up the right triangle are A and B. These are interchangeable. It doesn't matter which one you call A, excuse me, and which one you call B. Okay? Doesn't matter. The one that matters is the one you call C. C always has to be the side opposite of the right triangle or across from the right triangle. And we call this the hypotenuse. Okay, and it is always the longest side. Okay, it's always the longest side. And it always has to be the longest side because if you just think of just the theorem itself, if you're adding A and B to get C, then of course C is going to be the longest side because you're adding A and B. So A can't be longer than C because you've added B to it. Okay, makes pretty good sense. Sometimes you're going to be given a problem that's like a drawing of a triangle, such as this. Okay, this is what your homework will look like, and A and B and C are the values are given to you, and then you have to find the missing side. And sometimes it'll be given to you as a list of what A, B, and C are, and you just have to plug it into the. And we'll do examples of both. Okay, but the main thing is if you're given a triangle with sides written in, you have to know that the hypotenuse, or the C, is the one directly across from the right angle, and it's always the longest side. Okay. All right, so let's look at a couple of examples of how we put this into practice. So example number 1, I'm going to draw a little, my drawing skills, I'll just tell you, are pretty sad. That's why I don't teach art. Okay. All right, here is a right triangle. We know it's a right triangle because it has the little right triangle symbol. And I am given the information of 5 and 12 on these two sides, and I do not know what this side is. Okay, that side is not given to me. The first thing you need to do is you need to identify what A equals, what B equals, and what C equals. Okay, this is very important. So in this particular triangle, the two legs that make up the right triangle are A and B. They are the ones given to you. So it doesn't matter, right? You can say A equals 5 or A equals 12. It doesn't matter. B equals the other one. And in this case, C is our unknown. We don't know that one. Okay. And as far as shortcuts, for me, I'm totally fine with if you write just like that and just like that. As long as you know which one is A, B, and C, that's all that matters. Okay. And then your C, of course, is your unknown. So if you want to write it out in like a sentence form like here, or if you just want to label it around the triangle, I am fine with either one. All right. So again, let's think about our formula. A squared plus B squared equals c squared. The squareds are part of the formula, so all you're going to plug in, if you, actually I'm going to do that in a different color. Maybe, if I can get it erased. Yeah. There we go. So if you think about, the only thing you're going to be plugging in is the a value, the b value, and the c value. The squared, okay, or the 2 in the exponent spot, that's part of the formula. That's going to go in every single problem. So if we write this and we plug a 5 in where there was an a in the formula, we are still going to carry that squared. It's part of the formula. It still goes. And then plus, and then your b is a 12. And so we're going to plug a 12 in where there was a b, but we're going to keep the square. And then we don't know c, so it's just going to say stay c squared. Okay? Now, 5 squared is 25, so we're going to evaluate that. 12 squared is 144. Okay, if you don't know these, just punch 12 times 12 in your calculator. And then 144 plus 25 is, well, we'll do that in just a second. So you're going to continue the equal c squared because that's part of your formula, right? We don't know c yet. And then when you add 25 and 144, you get 169 equals c squared. Now, are we solved? Do we know what c equals? We know what c squared equals, but we don't know what c equals. And since we need to know a basic c, not a c squared, we have to continue solving. Now, remember on Tuesday, what did I say was the opposite of a square? What's the opposite of a square? Yes. No? Yes. Square root. Perfect. We know in math, to undo something, we always do the opposite, right? So if we've got a number multiplied by a variable, how do we get it off of there? We divide it, right? If we have a number added to a variable, how do we get it off there? We subtract it. You always do the opposite operation to undo something. Well, we need to get rid of that square on that c. And the way you do that is you take the square root of c, but whatever you do to one side in math, what's the rule? You do it to the other, okay? You do it to the other. So now we have if you take the square and the square root, they cancel each other out. And so your c pops out free, okay? And now you do have an individual c, which is what you needed. And then you need to take the square root of 169. Now, I will tell you that, let me check your homework and see, because I don't think your homeworks are all perfect. Let me double check. Okay, so to save yourself a little bit of time, you can actually, in your calculator, you can punch, if you have the option on your calculator, you can put the actual square root sign and then put 169 under it and hit equals. If it comes out a whole number, it means 169 is perfect, and you can save yourself the factor tree. But if it's not perfect, your answers can never be a decimal, because if you punch the square root of an unperfect number in your calculator, you're going to get an unending decimal, and you can't ever get an accurate answer. And you always want to leave these as accurate as possible. So in this particular case, if you guys have a calculator, and if you punch in the square root symbol, and then you put in 169 and you hit equal, what does anybody get? What? Yeah, 13. Because 169 is perfect. So your answer is that C equals 13. C equals 13. So I would say, just being careful wise, the main mistakes here are that people forget to take the square root there at the end, and they just leave their answer as c squared. And you can't do that because you're not looking for c squared, right? You're looking for c. And so you can't leave your answer as c squared. And then the other thing is the reason we did the work on Tuesday of learning how to simplify radicals is because if it's not perfect, you have to come out to the side and you have to do the factor tree and you have to make it an exact answer, which is a number on the outside and then leaving your radical just like we did on Tuesday. Okay? Any question here? All right, let's do another example. This time we're not going to have a drawing. We're just going to have a list. So this is example number 2. And we're given that A equals 4. B equals, we don't know. Okay, that's not information that's given to us. So I believe on your homework, yeah, it's a question mark. And then we're given that C equals 12. All right, so again, right, if you need it to kind of reference it, you've got A squared plus B squared equals C squared. That's always the basic formula you're going to use. And then it's just plug and chug, right? You plug in an A where there was an A, so we're going to put a 4 squared here. Now, we don't know B squared, so we're just going to leave it B squared. That's our unknown this time. And we know that it equals 12 squared because C equals 12. And so 4 squared is 16. We still don't know B squared, so we're going to leave it alone. And 12 squared is 144. And now this part is basic algebra. We're going to subtract 16 and subtract 16. And we get that B squared equals, and if you punch in your calculator, 144 minus 16, you get 128. Okay, now I'm just going to kind of scooch over here, so I'm just going to rewrite it up here just to give myself a little bit more room. All right, now I know what B squared equals, but I don't need to know what B squared equals. I need B by itself, so that means I'm going to square root both sides. And when I do that, the square and the square root cancel each other out, and the B pops out free. And then again, if you want to check 128 in your calculator, you can do the square root sign, punch in 128, but you're going to get a really long decimal because 128 is not perfect, which means you need to come out to the side here, and you need to factor. Okay, you need to factor the square root of 128 because we want to reduce it as much as possible. And it's even, so we're going to do 2 and 64. What's unique about 64? It's perfect. If you happen to catch it, that's going to save you a little bit of time. If not, you'll eventually get there. But perfect square 8s, they come out as 1. What can't come out is the 2. And so your answer is that B equals 8 square root 2. And that's okay, right? That's most of your answers are going to be like this, okay? All right, let's see. So if we are given, for example, number 3, we're giving that A equals, this one's going to look really weird, but that's okay. Promise it doesn't make it harder. B equals the square root of 75, and C equals, and that's what we don't know. All right, so don't let this throw you as far as how you start out. Your formula is still, right, A squared plus B squared equals C squared, okay? And we still leave the square there and we plug exactly what they tell you A is. We plug that whole thing in for A. So you get the square root of 6 squared plus the square root of 75 squared equals C squared. And we just learned a second ago what happens when you square a square root. The square and the square root cancel each other out, and the number pops out free. So on 75, right, when you square a square root, the number pops out free, and then equals C squared. And then 6 plus 75 is 81, equals C squared. And then again, right, because we want that C to pop out free, we always know that a square and a square root are going to make that happen. So we're going to take the square root of C, and the square root make the C pop out free. And then what's the square root of 81? Everybody recognize that one. That one's whole, or that one's perfect, so it comes out as what? 9. So C equals 9. And on your homework, you're going to have, I don't know, maybe half and half. Half are going to be, well, not even half and half, but close. You're going to have some that are whole, and you're going to have some that are square roots, and that's okay. All right? All right, let's do one more example. So this is example number 4. And let's do this one as a triangle. So let's draw a little triangle here. And here's our right angle. And we're told that we don't know this side. This side is the square root of 12, and this side is the square root of 19. Okay? Now, again, we've got our formula that we're going to use every time. And again, it doesn't matter A and B, right? We'll call this one A and we'll call this one B. Those are interchangeable, doesn't matter. So we're going to say we don't know A, so A squared. And B is the square root of 12 squared. And then C is the square root of 19 squared. Because we plug for the C value, right? We plug exactly what C was. And in this case, C was the square root of 19. So we plug that exact in. Now, solving it, we've got A squared right now is just going to stay A squared. We have the square root and the square, right? We know that anytime you square root, the number pops out free. And on the other side, on the C value, the square and the square root cancel out and the number pops out free. And then we need to get A by itself, or A squared by itself. So we're going to subtract 12 and subtract 12. And so we get A squared equals 7. Are we done? No. Cannot leave it as A squared because we need to know the value of A, not the value of A squared. So again, right, to break loose of that square, we do the opposite, which is a square root. Square and a square root, break free, but whatever we do to one side, we do to the other. All right. 7 definitely isn't perfect. Can we factor it? It's one of our prime numbers, so that just stays your answer. Okay? Pretty straightforward. All right. So for those of you at home, go ahead and click load on Kami and show all your work just like all of these slides. And then when you are done, hit submit and submit. If you have any questions, of course, you can email me.